Welcome to today's webinar, Getting Started with AWS IoT. Our presenter today is Michael Garcia. Michael is a Senior Technical Program Manager at Amazon Web Services, and in this role he works closely with customers and partners to bring more value to the AWS IoT platform and leads strategic initiatives inside the AWS IoT product team. Today with us we also have Gary Wicker serving as our webinar moderator. He'll be engaging with you and answering your questions throughout the presentation while Michael presents. Michael, welcome. The floor is now yours.
So hello everyone. Thank you so much for joining this webinar. As Ryan said, I'm working inside the AWS IoT team, and today we'll talk about the AWS IoT Managed Service. The goal today is for you to learn more about the service, to learn the basic concepts of the service, the different components, and also to get a view on how to get started with code, because the targeted audience today are IoT developers. So we'll spend approximately 1 hour together. We have slides for presentation that should last around 30 minutes. Then we'll have the hands-on part where you will see a live IoT Starter Kit being used and connected to AWS IoT service. That should last 15 minutes, and then we'll have some links for you at the end so you can get started easily, and we'll go to Q&A for the last 15 minutes. All right, so most of you probably seen this kind of slide saying that in the future, in the near future, there will be billions and billions of connected objects. And you can see this trend today because if you take a look around you, a lot of objects from your day-to-day life are already connected. And when you try to create IoT application as a developer and you have millions of objects to manage, you will have a few challenges. First one is to be able to produce code for any kind of platform. You will also have to manage scalability. So if you create the infrastructure yourself, it might run easily at the beginning where you have a few connected objects, but then what happens when this number will grow up a lot, like millions of objects? Then there is also the topic of security and management. So security is a very important part in IoT because you will be able to control physical objects and then act onto the physical world. So you should be very careful about the kind of permission that you give to people and what your objects can or cannot do. Then also the goal for you, you're a developer, so you will want to write code and add new feature to your application. So how can you easily interact with your objects without wasting time? And finally, a lot of the value of doing IoT is in the data that your objects will be producing. The first step is connecting an object and managing a fleet of objects, but then that's really the start. You need to exploit the data, share some of the information that you will collect with the API with your partners or with your customers, being able to do analytics on patterns and those kind of things. So to solve all those challenges, we came up with AWS IoT. So as you can see on the screen, there are many components in the service, and we'll basically go through each and every one of them. Those components are designed to help you solve those challenges so you can focus on your IoT application. You can deliver more and more features without worrying about the underlying infrastructure. So the first component are the SDK. You will need to put code inside your connected devices so they can connect with the platform and they can execute actions. We have a few SDK that you can see here on the screen, and you have a link at the bottom to go to the SDK page, and those are called the device SDK because those will reside onto the connected objects. So as you can see, you have a C SDK. This one is more targeted towards microcontrollers, but you also have JavaScript SDK, Node.js, one of my favorites. And you also have Java and Python available, one SDK for the Arduino Uno, and then mobile SDK for Android and iOS. So with those SDK, it will be easy in a few lines to get connected to the service and to exchange information with the platform. So let's say that now you've written some few lines of code, then you need to connect to the platform. And for that to be really secure, you will have authentication and authorization built into the service, so you don't have to worry about it. So first, let's start by saying that the security around the AWS IoT is strong, and the way objects are connecting with the platform is using TLS 1.2 with mutual authentication. So it means that AWS IoT knows which devices are connected, and also that devices knows that they are connecting to AWS IoT and not some other platform or person impersonating the platform. All right, let's start at the beginning and remind you of a few concepts to make sure that everyone is on the same page regarding security. So what's a certificate? So when you go onto a website, so for example, you can imagine going to Amazon.com, you can see in your browser that you will have a certificate that is presented. The website will present this certificate to you and have associated with that certificate a private key. That's the key in red. And this one contains the secret. So this one you should never lose, and you should protect it at all costs. The certificate, on the other hand, is something that is public, right? Because when you try to connect to Amazon.com, you will see this certificate appearing. This is something that you can download, and it will give you the guarantee that the website is indeed who it says it is, and that you can connect, and that the connection is encrypted, so no one can, listen in on the data or tamper with it. And in this scenario, you are anonymous. The website does not know who you are. That's why on most of the websites you have to use a username and password so the website can know who it is. With IoT, we want something that is even more secure than that. So you will have the same concepts when you connect to AWS IoT. AWS IoT will show what we call a root CA. Ours has been generated by Symantec. So we'll keep this private key, the red one, very secret, and then we'll expose the certificate so you can know that as a device you're connecting to AWS IoT and no one else. So that's the part on our side. And then on the device, there will be the same process, meaning that the device will have a private key. This private key should be stored on the device securely, and the device will expose to AWS IoT a certificate to authenticate itself. If AWS IoT knows the certificate and knows that they can authorize the connection, then the connection will be open. Otherwise, AWS IoT will refuse the connection. So again, this gives you the guarantee that the link and the communication is encrypted, but also that you have mutual proof of identity. And that is very important because as AWS IoT, then you can revoke the access to the service by revoking some of the client certificates. Right. So now you are connected, authenticated. Then comes authorization. It's the permissions and the right to perform an action now that you are connected. And again, you will need to have segregation of the permission, and with the AWS IoT we have a fine granular system in place, which means that for example, if your device publishing the temperature in red, that will go into the platform, and if you're a fan publishing some metric as well in green, that will also go into the platform. The fan in green is not authorized to listen to what the temperature sensor are sending. But, for example, an authenticated user in blue on the right can listen to both data, but is not authorized to publish data. So you can see that with the system you can pair application and users to a device, to multiple devices, and you have a lot of control over that. All right, so next is the actual broker which you will be connecting to. We call this component Device Gateway, and it's supporting MQTT, HTTP, and also WebSockets. So it will be used to exchange data, messages between your device and AWS IoT. I will only focus on MQTT in this webinar. And for those who don't know, MQTT is a protocol, and we are not, in this case, it's very efficient to use this protocol because it's a very lightweight protocol. So I will let you do the research, but here is one source of comparison. Basically, you can just see MQTT as another protocol on top of TCP that is very, very lightweight. So it's well fitted for IoT and for connecting objects that can be very constrained and that do not have a lot of CPU, a lot of RAM, and that runs on battery, which means that you have to save energy. It's a little bit different than HTTPS because it's based on a publish-subscribe pattern, which means that, for example, if you have a subscriber on the right and a publisher on the left, they can both use what we call a topic. And by the way, this is not specific to AWS. MQTT is one of the standard in the industry, and all of this is just related to the MQTT specification. So let's say you want to, as a subscriber on the right, listen to what the device on the left is publishing. First, you will subscribe to an MQTT topic called My Topic in this case, but you can choose any name that you wish. On the left side, then the device will publish a message to a topic. So in this case, it will publish the message to the topic called My Topic. And as you are subscribed, you will receive instantly this message. Of course, you can have multiple devices publishing to the same topic and many subscribers that are subscribing to the same topic, or any kind of varying combination. So this will enable you to connect a lot of objects and listen where it's relevant. One of the advantages of the service is that instead of you worrying about the infrastructure, we do that for you and we scale the underlying broker for you. So you don't have to do anything on your side. This is done automatically and transparently. And if you have millions of publishers from one day to the next and millions of subscribers, that is, we will scale the platform for you, and you don't have to worry about it. So it's a really a good solution, and will let you focus on your application. Next part is the registry. As soon as you will be connected device, you will have a fleet of devices to manage, and you will probably need to name those things. You will probably need to give them attributes. So for example, if I have connecting solar panel from a solar farm, one of the attributes could be the location of the solar farm. And I could put this as an attribute, and then you could query, devices to know which attributes they have. So it's really for managing your fleets. That's what the registry is doing. Next is what we call device shadow, and it's a very important part of the service and the value proposition. Why? Because your connected objects that will be in the field will not be connected all the time. Remember, those are not servers, those are connected objects in the field, so it means that some object will go to sleep because you want to save battery. So you only wake when you need to be woken up, and most of the time you will just be sleeping, so not connected to any platform. Maybe you will lose the connection. Again, you're in the field, so it's not a very reliable connection, and you might have intermittent connection. So to go away around that, this is why we created device shadows. So basically, when the device is connected, it will publish, its state to AWS IoT. So for example, if you have a temperature sensor, it will publish the temperature, let's say 23 degrees. And then on the other side, as a developer, you will need to create IoT application, right? So That could be mobile application, that could be web application. And you will interact with the shadow directly, not the device, asking shadow, hey, what is the latest temperature? And then you will get an answer. And you will always get an answer because you are asking this to the shadow REST API and not to the device directly. So here is an example of what the device shadow is doing. Device shadow, you can see it basically as a data store that will save a JSON document, and the JSON document is formatted as follow, as what you can see on the screen on the right. You have a state part because we retain the state of the device, and then in grid is the desired part. So desired is when you want to give an order to your device. So this part can be controlled by a human, by web application, or by a web application. Then you have the reported part in red. This part is updated by the device, and it's when the device say, hey, I measure 23 degrees, I measure 25 degrees, etc. And then you have the delta in yellow. So this delta is computed by the service and can be sent to the device, so it knows that there is a difference between the state he's in, again, the reported state, and the state it needs to be in, the desired state in green. So when it catches the delta, it can perform an action. In this case, it's reporting the color green, but we are saying to the device, hey, switch to red. So if it catches the delta, it can then switch to red. Here is the same thing with an engine and the workflow. So starting, the engine is off, the device will publish that. Then on the mobile application, you can say, okay, you need to put the engine on, and remember, you're just interacting with the Shadow REST API. As soon as you do that, the AWS IoT computes a delta, and then will send an MQTT message on the reserved topic. And the connected object is listening, is subscribed to this topic, so it will catch this notification and this delta. So then it knows that it has to put on the engine, it will do so and report to the shadow, okay, it's good, the engine is now on. And then you are back in sync from a device shadow state. All right, so now you've connected the device, you're able to send messages, you can create IoT and web application to see the state of your devices. What more can you do? Well, you didn't do anything with the data yet, so we need to take care of that. And that is why the Rules Engine is around, is to enable you to route the data to the appropriate AWS service or to any third-party service, so you can use the data that is sent by your fleet of connected objects. So the idea behind it is really to enable you to perform and to accomplish use cases. For example, you might want to save all the data that your devices are sending. Why? Because later on you want to do big data. Maybe you already want to do big data. So you can create a rule to send all the data to Amazon S3, for example. And that is just configuration in the AWS service. You don't need to code anything, you just need to configure a new rule. And then later on, you can pick up the data on S3 and do machine learning or analyze the data. In the same way, you would be able to send the data to other AWS service, and that's what we are going to see now. So let's say you have a fleet of devices here, different building with different sensors sending data, and you want to push that into a DynamoDB table because then you have a web app, for example, that needs access to that data. You will be able to create a rule to select the data, filter the data, transform the data, and then push that into DynamoDB. You can push the data as is, but the rules engine is a little bit more than that, and it will enable you to also, transform and filter. So in this example, I'm just selecting the data that is coming from a particular sensor in building one and pushing that to DynamoDB. Let's see how you can create a rule in the rules engine. So the language that you will use to create a rule is one that is known amongst the majority of developers, and that is why we chose it, because we didn't want to do something specific. And a lot of developers know how to write some SQL code. So that's an equivalent syntax that we choose for you to be able to create a rule. So the first step is to select the data. So on the right, you can see a sample payload. And that is what the connected device is sending. So you can see it has an ID, it's sending the temperature, the humidity, some GPS coordinates, and some other information under the node called A. With select, you can just select star, which means you will select the whole payload and send that to the rule, or you can go deep into the payload in JSON and just select the field that you are interested in. So for example, I could select just the latitude inside the GPS coordinate. But as you can see, you can go deep to many other levels to select only the data you want to filter. So that is just selecting the data from the JSON payload. You can also use SQL expression. So in the documentation online, you can find, every SQL function that is available. But here are a few examples. You could, for example, use a MD5 function to create a hash of your device ID. So you can see how the rules engine is helping you to transform the data. Next is selecting from a topic, because you will subscribe to an MQTT topic and the rule will listen to an MQTT topic. So as soon as a message is sent on the topic, then the rule will be evaluated against the message. So you have what we call the hierarchy of topic when you are using the MQTT protocol, and you can play with some special characters. For example, you can see at the bottom the MQTT topic is my/wildcard/plus/topic. That means that the plus can be replaced by any character. So you will listen in every topic that exists that are in the form of my/wildcard/something/topic. And you can use another character that is the hash to replace with any value after the hash as well. All right, and the last part is the where clause, where you can filter on a condition. So for example, you have a temperature sensor sending 23 degrees. You want to trigger the rule only if the temperature is higher than 50 degrees. So this is where you can put your condition to filter even more on the data. And then when your rule is triggered and you have selected the correct data, what will you do? Then you can take an action. So this is where you will route the data to an AWS service. And this is the most important part, because we are connected today to a lot of AWS service. You have a few on the screen, but now there's even more. And you can send the data directly, for example, to S3, to DynamoDB. You can use SNS to alerting if you want to send email or a mobile notification. You can push messages in a queue. You can push messages to Amazon Kinesis, and then can be picked up by other AWS service. If you are using SNS or Lambda, for example, then you are able to perform any action. If you wish to integrate with some third party or send the data to another platform, with Lambda, you can do anything that you want. For those who don't know Lambda, you can see that it's an event-driven processing service. So basically, when a message arrives, it triggers what we call a Lambda function. You can write any code in that Lambda function and do anything that you like with code. So you can call any API, third-party API, for example. So you can see how the rules engine is powerful. It will really enable to transform you the data, and this is where you will be able to achieve use case, for example, storing all the data onto S3 and then archive it to Glacier, or you can use Lambda to target a third-party API, or you can use notification system, and then you can see how you can start to picture and build your IoT application using the rules engine. All right, so let's give you a few examples on how to get started, because that's the goal of the webinar today. We have for you what we call the IoT Starter Kit and the AWS IoT Button. So the AWS IoT Button is a small button for those who are customers of Amazon and know the dash button already. It's kind of similar. You can go on in using the link at the bottom of the slide to have more details, but basically you can order a button online. It's Wi-Fi connected, so you will have to configure it so it can connect to the Wi-Fi or your home or your workplace. And then you have a wizard to go through that lasts a few minutes, and that will get you set up with a rule in the rule engine, a Lambda function, and posting that to SNS topics so you can receive an email. So the thing that it is doing is that as soon as you push the button will connect to the Wi-Fi and send a message to AWS IoT, and this message would be forwarded to a Lambda function that is pre-populated, and we send that to an SNS topic. So this is an example of how you can, connect hardware to the service. This is really meant to be an educational experience for you, because you will be able to see all those components, and then you can change to do anything that you want. So you can change the Lambda function to, for example, call another API. So you could integrate with Twilio, for example, or do anything else. So you can toy around with the AWS IoT service easily with the connected hardware. If you want to use your own sensor, because you already have a use case in mind, for example, you want to do a connected home or industrialize smart metering, you can buy one of the IoT Starter Kit from one of our partners, manufacturers, that you can see on the screen. And those boards, some of them have a built-in sensor that you can use, and some of them have sensors that you can easily connect to and use. Those boards are pre-flashed and pre-configured to be connected to AWS IoT, and we work with those manufacturers to provide you a good onboarding experience. You are not, this is not mandatory. You can totally take any hardware that you already have and connect it to the service following the documentation. This is not an obligation in any way. It's just to make your life easier. If you don't have any hardware and you want to get started easily, you can just check those online and buy one and get started. By the way, it's the same thing for our SDK. The device SDK that we provide, you don't need them to connect. Again, we're using MQTT, that's standard. You can use any third-party MQTT library with a client certificate to establish a connection, but we do recommend that you use them because, as soon as other feature will arrive, then we'll maintain the SDK. So we are doing, all the work of integrating that for you. So again, it's time that you can save and that you rather spend on building your IoT application. All right, so that's it for the demonstration and the slides. I hope you had a good overview of the different components of the AWS IoT service. And now we will switch to my computer to show you a demo and show you one of the AWS IoT Starter Kits. All right, so now you can see that I'm on my screen. Let's try to show you the device on the camera. So here you can see an AWS IoT Starter Kit. It's an Intel Edison. So the small chip that you can see here is actually just the Intel Edison, and the rest is just called an extension board. And it's here to make your life easy because you can connect a lot of sensors. Today, we will be connecting this LCD screen, so you can see messages that will appear on the screen. But as you can see, there are a lot of other ports, and if you take a look online, you can connect a lot of sensors. You can connect temperature sensor, humidity, a flame detector, a proximity detector, a lot of them. So today we'll be using the AWS IoT service in the Oregon region. So let's hit the button Get Started. We'll go through the code, and we'll go through what you will have to do if you buy a kit and you want to connect it to AWS IoT. So the first thing is to create, a virtual representation of your device. And that is called a thing in AWS IoT terminology. And the thing is, connected to the shadow, the device shadow component that we explained earlier. So I will create first a thing type because let's say that in my experimentation I will connect many AWS IoT Starter Kits. So I want, for example, to create a new tab, Diaries Starter Kits, AWS IoT Starter Kits. And I will want to add an attribute. For example, each of those kits have a different manufacturer, and I want to be able to trace that in the registry. If I had to connect, for example, a solar farm and I had solar panel, I could have created a thing type that is a solar panel, and same with the attributes like location, manufacturer, that each and every one of the solar panel will have. And you get kind of a hierarchy and a link between those two things. So now I can go ahead and create my kits. I would just call it Edison. And I can choose a device type. So here I will choose Starter Kits, and you see that I have to fill in the attribute key that is manufacturer. So in this case, it's Intel. I can add also other attributes that are specific to my thing if I want. So let's just create this. Okay, so now you can see in the console, I have a thing, and I have a starter kit, and there is a shadow that is associated with the thing. Okay, so now we need to go onto the device. I will be using the console for that. Why? Because remember, we need a client certificate to connect to AWS IoT. So I will have to generate that on the device and ask AWS IoT for a certificate, so then I can connect to the service. So let's first connect to the Intel Edison. All right, so here I'm logged into the Intel Edison, and you can see that I'm in a folder called certs. I prepared a script to generate some of the components that we need today, but I will show you the what's inside the script. It's just for me to make my life easier during the webinar. Instead of typing all the command, I can just execute the script. But I will show you everything. So the first thing is remember to get the root CA of AWS IoT. So we talked about this at the beginning. It's a certificate that is signed by Symantec that AWS IoT is using. And we need that as the device because when we try to establish a connection, we want to make sure that we are really connecting to AWS IoT and not something else. And this is what the root CA will give us as the guarantee it will give. So I will show you what's inside the script. I'm just doing a wget, so basically just downloading from the Symantec website the certificates. And you can find, this address and instruction in our online documentation. So let's execute this script. Okay, it's downloaded, and I can see now that it's in my folder. All right, here is the root CS script. Now I need to generate a private key because I don't have one, a certificate, and a public key. And the certificates and private key that I will generate will be used to connect to AWS IoT. So this time, remember, you have to show mutual proof of identity. So as a device, I must show the certificate to AWS IoT. And for that, I have another script that is called generate keys and cert. And it's just an AWS IoT command line using the CLI, and it's called create keys and certificates. So I'm asking AWS IoT to create the certificate for me and register it. So let's do that. All right. Okay, and now we can see that those components are here. So what did it do exactly? If I go back to the console and refresh, let me do that, I will see that now the certificate is provisioned. What I ask with this command line is, please AWS IoT generate a certificate private key and give that back to me so I can later on, when I try to connect, show this certificate to you. There is only one thing here, is that, remember, I told you that the private key is really critical and that it should never leave the device because that's where the secret is. And using that, I'm asking AWS IoT to generate it for me and to give it back to me. So this is used just for demonstration purposes, so you can understand, what is the client certificate, what is the root here. But in an industrial use cases, we have many other ways to sign certificates, register your own root CA with AWS IoT. You can import your own root CA into the service. This will not be the objective of this webinar because, again, it's just to make you learn the basic concepts. But rest assured that we have industrial ways of doing that. If you're interested in knowing more, I would suggest that you check out also the microchip partnership that we have, where we use crypto chip that are highly secured onto the devices to establish a connection. Right. So back to our use case. We have a thing, we have a certificate, and our device will now be able to connect to the service using the certificate so we can authenticate ourselves. But remember, we talked also about authorization. Do I have the right to perform an action? Not yet. So for that, I will create what we call a policy to give rights to the certificate. So in this example, I will just give, all permissions. Don't do that in production, of course. And you can select here with a good granularity what action you want to perform. So for example, just publish data or just subscribe. In my case, again, I will just authorize everything. And on which resource. So here I could name, MQTT topic to say, okay, I will only be authorized to publish onto the topic called something/topic. Again, now example, I just put star, allow everything, but this is where you could restrain and scope down the right of your devices. Okay, so the permission is here. I need to attach now this policy to my certificate. And with this operation, what it gives me is that when I connect as a device with this certificate, and I will inherit those permissions, so I can do anything. And the only other thing we have to do is to attach the thing to the certificate to say, okay, the Edison kit is linked to this certificate. All right. So now we are able to establish a connection. Let's go into a source folder that I prepared, and you can see there is already code available. It's just to show you the demonstration. So the first thing I want to do is to make sure that my LCD screen is working. So here is code just to make sure that the hardware is working. So it should print hello world. Okay, so here you can see hello world and the screen turned to green. All right, that's the first piece of code, and here it is. So this code is 34 lines of code. I'm using a library called Johnny.io that is here and that supports the Intel Edison and is using JavaScript, but you can find, depending on the kit that you are using, other libraries. I just wanted to show you that this code is just related to the device. There is no AWS code there. It's just code that will give you the ability to manipulate, the sensors and to retrieve data and to act on the different actuators. Then let me show you what we will do is to publish a message to the device. So this is code that is using the AWS IoT SDK, as you can see on top. And this is where we will use the different, certificates and keys that we created. So remember, I have the root CA that give me the guarantee that I'm connecting to AWS IoT. Then I'm presenting to AWS IoT my client certificate. And then the private key is just for my usage when established the connection. It's not exposed to anyone else. And what I'm doing is just establishing a connection here, connecting, and publishing a message, hello world, onto the topic, MQTT topic called Edison. So before activating this code, there is an MQTT embedded client in the IoT console that is very useful because it will enable you to simulate devices. So here I can use it and connect myself to the service. And now I'm connected and I can subscribe to a topic, publish to a topic. So let's subscribe. If I subscribe here to the topic Edison, all right, I'm listening to the topic now. By the way, this is using, a WebSocket connection. And here I'm back onto the device and I will try to publish the message. So let's execute the piece of code I just showed you. All right, and you can see that a message has been published. Let's go back to the console, and you can see that here we indeed saw a message onto this topic, and the message was hello world. Okay, so now we prove that our Intel Edison is connected, and it can send data to AWS IoT. We can also use the shadow, and here is the code for shadow. So again, it's only AWS IoT SDK code. It's 30 line of code, and you can see the interesting part is here that we are listening to the delta. So the difference in state between what is the desired state and reported state. So let's try to execute that onto the device. Okay, so now I'm listening to the shadow and we'll perform a real shadow update. So for that, I can select the device in the console, the thing. I can go to update shadow, and you can see here there is a desired part. There is no reported part yet because I didn't implement it in this example because the device is not really, sending any kind of data like temperature or other things. So I just have a desired part, but normally this is where you would get, the reported state here. Okay. So what I want the device to do is, for example, to say webinar and to switch to purple light. If I click update shadow, then it's using, the equivalent of the REST API to perform the update. So this is what your IoT application would do. And if I go onto the device, I see that I receive some data, and the data is the delta between the desired state and the reported state. Here we don't have any reported state, so the delta is the whole desired state. You can see that I have the message. But nothing happened on the device because I'm just listening to the shadow and not doing anything else. if you mix the two parts of code together, that is what the demo.js is looking like. Then when I receive the delta here, I will perform the action of changing what's appearing on the LCD screen. I just wanted to show you separately the hardware code from the AWS IoT device code, so you would know the difference and don't be confused by that. So let's execute this one now. Okay, we're connecting, it's connected. So now, if I perform a shadow update, then it will really the LCD screen will change color because we will perform an action as soon as we have the delta. So let's say we want to turn the screen to red so you can see it well on camera, and I will be pushing the button now. And here you go. Here the text changed and the color as well. Let's do one more in blue and say hello AWS and update the shadow, and here it goes. So you can see now that it changed as well color. So this is just a very simple implementation. As you can see, I did not even implemented the reported parts because I don't have anything relevant to show in this use case. I just used the SDK and shadow to control the LCD screen, but you can see the power of the system. All right, so now we'll just switch back to the presentation to go through the last section very quickly so we can take some questions. All right, so the first thing is about the pricing, and you can get started today and just know that you have a free tier of 250,000 messages per month for 12 months, so that's quite enough to get you started. Otherwise, we are billing per million messages, and any messages that is forwarded using the rules engine is to one of the AWS services is free. You can go to see our YouTube channel. There are a lot of good IoT sessions from reInvent last year. This should help you get started as well, or dive deeper if you want to. And the first page you should be taking a look at is the developer resources on our website, because there you have everything that is gathered into one page with the webinars, video, link to SDK, and blog post. I'd also wanted to share an information with you is that we have a Dev Day coming up end of October in Austin, and you should check out the website link below, and you will have IoT workshop during those days to have hands-on experience. So if you're around Austin, I would encourage you to go there, and don't hesitate to check our website regularly because we are doing those kind of events regularly as well. All right, so thank you very much for your attention and for joining us today, and now we'll be taking